That doesn't mean. Yeah, I use the excuse I'm 80 years old.
I'm a member, this is off topic, so I don't want to take a lot of time talking about it, but I'm a member of three local clubs. Is the Indian River Club another one I should consider?
Say that again?
I'm a member of three local clubs.
Right.
PCARS and two others. Is the Indian River Club another one that I should consider?
Well, depending on where you live, it's in Merritt Island. We meet at the River of Life Church on State Road 3 or Courtney. It's just north of Publix.
Yep, good.
It's now on Thursday nights because the church board of directors said you can't have it on Tuesday anymore.
Yeah. Okay.
So it's now Thursday at 7 o'clock.
Okay. Yeah, it's a hike for me, but I still wouldn't mind supporting a local club.
Oh, it's a nice club. They're all different.
Yeah, that's correct.
They're all different.
The three that I'm in is completely different.
Yeah. So what's the advantage of joining the other?
They're different.
They offer.
Oh, okay.
The Indian River Club, it kind of concentrates more on emergency communications.
Okay.
And we do like a monthly drill to do simplex stuff to see if everybody can contact one another, assuming you have no internet or anything or no repeater.
Right.
So you do that.
Things like that.
Repeaters, you do that just simplex.
Yeah.
That's cool.
And most of the people around the island can make contact.
Cool.
That's probably the primary emphasis.
Yeah, so needs to use the auto patch to make phone calls. So I joined from Ticeville all the way down to Palm Bay.
You have access to all those.
All the auto patches, yeah. So anyways, that was the reason why that was a long time ago. So
Yeah, I remember that too, yeah.
And then most of the people in the Indian River Club participate in what we call SMOC. Ham spelled backwards. And we meet for breakfast at Umpa's restaurant on Friday mornings and talk about sometimes ham radio.
Most of the time.
So you do. I chose to drop out of both. I dropped out of both the Titusville Club and the Indian River Club.
Say that again, Chuck.
I dropped out of both the Indian River Club and the Titusville Club. The Indian River Club was not very hospitable when so quit that one. And but I'm also in the Silver Springs Club over in Ocala. That's where I started out ages ago. They have a very good ham fest, by the way.
Okay.
But I really enjoy PCARS, so anyway.
Yeah, PCARS is good club.
PCARS is like, I mean, I am running to keep up.
Well, that's the thing about PCARS is if you're into training and having good repeaters and having good like local VHF repeaters and a club station that you can use.
Okay.
Like that's where PCARS just nails it. Like I think it's probably the most active clubs in the.
Yeah, well, it's the largest in Brevard anyway.
So there's other clubs that do other things, but
I see.
Right.
And I'm in two of the clubs. One of them is through my work, but that's just
the NASA KSC club has a better station, but you have to be a contractor, a badge contractor or NASA employee to be able to access it.
Like I can't.
It's much more restrictive.
Yeah, I can use their repeater because they don't
Right.
have a lot, but you can't be in that club.
I see.
So
Thank you.
Well, you can join.
okay.
Yeah.
Oh, but you can't access the station on the base. That's right.
Oh,
That's right. Yeah, that's what it was.
Okay, so we're going to talk about coordinate systems and phasers. Hey, Walter.
Right. Popping in and go with Phil.
Okay.
Get some pictures.
A little bit on rectangular coordinates and polar coordinates. Very little on phasers and a little on logarithmic axes, so we can represent a wide range of frequencies.
I think we're quite two phasers yet. We haven't had even the starships in space, you know, with phasers and protons.
Not exactly the same thing. Okay, so we normally will plot things on what we call rectangular or Cartesian coordinates, where you have an X and Y axis. And we represent if we're plotting impedances, let's say, that we've been talking about, we'll plot the real or resistive part of the impedance on the horizontal axis and the imaginary or reactive part on the y-axis. And then we draw that vector and it has an angle, so that's the phase angle or phase shift. And it's also part of power factor, which unfortunately I think they've kind of moved all of the power factor questions. I'm not sure why. But basically part of this, some of the exam questions will have you plotting points on a graph or picking the appropriate point. So like I said, we plot the resistive part on the horizontal and the reactive part on the vertical or y-axis. And remember that the capacitive reactance part is always going to be negative. So when you're using rectangular coordinates to graph the impedance of a circuit, what do the axes represent? These are all long answers, so you can't use that.
Yeah, great. Which I'm not sure anybody needs to know whether I'm there or not, right? We have to rush on in through all the class.
We have any guesses yet?
Yeah.
Dan? I forgot. Why do I have the green square? What did I forget to do? Maybe I didn't close the previous one.
Yeah, and I think it has something somewhere along the lines that and I don't remember if it's in Zoom or the other one, but something set limits to what's being transmitted.
Well, let's take a look.
Yeah. Okay.
All right. We didn't speak up.
Oh, I did. I kind of mumbled. Because
Because you didn't want to be wrong.
I didn't want to be wrong in public.
Okay. Well, we won't make too much fun of it.
Oh, good. That's good. Well, go ahead. I don't care.
What is the impedance of a pure resistance plotted on rectangular coordinates? Shoot, where is, not what,
Oh, wait.
where is?
Oh,
So where do I draw the line?
it's the slanted at 45 degrees. And I don't.
No, so I got a pure resistance.
Oh, pure.
That
Okay.
means their
Oh, okay.
reactance is what?
Yeah.
Zero.
Yeah. Okay, so B. Oh. All right, sorry, no. Don't follow me next time.
Pure resistance, horizontal axis.
Oh, that's right, that's in the other slides, okay.
There was no reactance, so there's no plus or minus Y. Or X. Which of the following represents pure capacitive reactance of 100 ohms in rectangular notation? So they're showing you the impedance. So Z is equal to one of those things. So which is the correct one if I have a capacitive reactance of 100 ohms?
Pure,
Pure resistance would be 0. Pure capacitive reactance would be
100.
what kind of 100? Negative 100.
I'm glad I'm in smart class. Okay.
What does the impedance 50 minus J25 represent? So the first number is what? Resistance, right? The second part is reactance.
It's mine.
So 15 minutes. Okay, this is. So what was that?
But now you're not supposed to ask people.
We have the same test.
Yeah, if you sit 4 apart in Gary's test, you probably get the same one,
Oh,
except you don't get to sit where you want. He has assigned seating.
oh, geez.
I'll figure out how to tap out Morse code.
Yeah.
That's why you're taking Morse code.
Learn A, B, C, and D.
Okay, so is it the inductance?
So the
We have a
negative.
minus
So it's negative.
minus J 25 would be. Remember, negative is a
It's not.
pass.
That's what Cassidy is.
So
Yeah, that's right, okay.
that's the given range, and then it goes. Yeah.
I see.
Negative is always capacitive reactance. If the impedance had been 50 plus J25, then it would have been 50 ohms resistance and 25 ohms of inductive reactance. So it would have flipped it.
Okay.
Yeah.
Okay. I know the slides are on there, but I'm trying to really highlight areas of many weaknesses.
You had these in these two, right? Of the slide. There was in Dropbox, there was a PDF version of.
Yes. Yeah. Yeah.
Yeah.
Because not everybody can open an ODF file, which is open document format,
Mhm.
which Microsoft doesn't exactly comply with.
Right. Right.
So
Yeah,
if you open it in Office, it may not be formatted right.
okay.
Depends on the chart. So
A PDF.
PDF, anybody should open. Okay, so to find impedance, we plot the inductive reactance on the positive Y, the capacitive reactance on the negative Y, and then basically add them together to see what the result is. So it'll come out either positive or negative. And then we plot the resistance on the horizontal or x-axis. And the length of that vector So that wherever that point is going to be the magnitude of the impedance.
You have a picture of that. I think
A picture of the square root of x squared plus y
squared.
squared, huh?
Oh, yeah, okay, that's good.
Like that?
Yeah, that's
Okay.
good. Okay, could you, so what are we talking about now again?
Okay, we plot reactance here on y.
Mhm. Right,
And we plot resistance over here. And then where these 2 points intersect, okay, are your two values in the impedance formula, R plus X, or minus X, depending. And this vector, okay, is the magnitude of the impedance at this phase angle, like we did earlier, where we did the arctangent, which would be the y over the x in this case, or reactance over resistance.
okay.
So if we do polar coordinates, then we show the magnitude and the phase angle when we do it on a circular plot. Where if you have a positive phase angle, it means it's an inductive reactance, and a negative one means capacitive reactance. It's always capacitance is always negative relative to inductive, excuse me. And then there's phasor diagrams, which they sometimes use to show the phase relationship between resistances or currents or voltages. So if we do a polar coordinate system and we plotted that same thing, we would, instead of having X and Y points, all we're going to have is a vector of certain length at a particular angle. But it's going to be the same length vector that we did on rectangular and the same angle. It's just you have to plot it by finding the angle and the length. And this is the only thing I could really find to represent some phasors. They're really just vectors. I'm not sure what the great distinction is. Fortunately, there's only like one question about it. So what coordinate system is often used to display the phase angle of a circuit containing resistance, inductive, and or capacitive reactance? So I'll tell you right off the bat, because we haven't talked about it yet, it's not a Maidenhead grid.
Isn't that the grid coordinates for a map? Like EL 98?
Right. So it's the whole globe broken up into geographical sections, and they have two letters, two numbers, two letters. It goes up to 6. Most of the time, you only see 4. Like we're EL 98. Where I am in Merritt Island, I'm EL 98 PI. Not sure what we are down here, but it's EL 98, 2 other letters.
I am right on the border of EL 98 and EL 97, I think. I think on the other side of the road is EL 97. Polar.
Mhm.
Okay.
I agree.
So this building is in EL 98 PD.
How are impedances described in polar coordinates? What's different about if you do it on a polar coordinate?
C.
See, Charlie.
Charlie.
All right. Phase angle of magnitude. Which of the following represents a pure inductive reactance in polar coordinates? Inductive reactance means it's positive, right? What would the phase angle be if there's no resistance?
90 be straight up and down. So, see,
See.
Down, Charlie out.
Speaking of that, all day, man.
What kind of diagram is used to show the phase relationship between impedances at a given frequency?
Oh, definitely that diagram.
yeah, it's got to.
I think I mentioned there'd only be one question about it.
There it is.
Razor, that's it.
In doubt, Charlie out.
Okay, now we get to do some plotting. Which point on figure E5.1 best represents the impedance of a series circuit consisting of a 400 ohm resistor and a 38 picofarad capacitor at 14 megahertz? Now here you have to remember a formula. What's the formula for capacitive reactance?
F equals 2 pi square root of LC.
No, that was resonant.
The resonant.
Reactance is 1 over 2 pi F C. So you know that the R value or X axis is going to be 400 ohms. And you know that it's capacitive, so it's going to be on the minus side. So we pretty much know it's here, and it's going to be down here somewhere. In this case, it's easy because there's only one place it could be. So you don't have to calculate it. But if you calculated it, huh?
What magic are you using?
Yeah, how did you get there? 400.
I came over 400,
Okay,
that's resistance.
okay,
And I know that my reactance is negative,
okay,
capacitive,
okay.
okay? So I can calculate it with the formula and come down, or I can come, and it's got to be on this line. Well, there's only one point. So it's kind of has to be that one,
Gotcha.
which is going to be around 300 ohms reactance. And if you did it in your calculator, you'd come out approximately 300 ohms.
So it's 2 pi times 14.
2 pi F. Okay, have the frequency.
Right, times 10 to the 6th times 38 times 10 to the minus 12. So let's do the math on that. See
Okay.
that answer.
Well, subtract your,
So it's 1 over.
now the first one's easy because there's only one place it could be. Some of the others, you have two options. So you might have to calculate it.
And then what it feels like to get in a riptide. Think you're just swimming.
So it should come up with 300.
It did came up with 300, 299.
Okay.
So the question is, why did not it come up with a negative number?
Because you have to put the negative number in yourself.
Because it's capacitance.
Right.
Okay, got it. So I did get 300.
Okay.
200.
So now we have an 18 microhenry inductor and a 300 ohm resistor. So,
It's gonna be 1, 3, or 8, right?
well, okay. We know it's a positive resistance, so that's 300. And we know it's inductive, so it's going to be up here, right?
3 or 8.
So if we come up here, it could be 8 or it could be 3.
Yes, I'm sure the numbers, it can't get 100, so it's gotta be 3. I mean, the math wouldn't work out. It's,
Yeah,
I,
you could probably estimate it without
these
doing the
things work
calculator to
good.
figure out.
Are really make a difference. At least one of my investments really paid off in 2 years. Big time.
I got 396. so
Trying to
we get 4.
recover my glass in my cup.
Well, let's see if you're right. How about that? 396.
What?
I just gotta memorize the stupid formula.
No, my,
Yeah,
It gets written down.
I'm looking for the cup.
that's a
I'm
formula
looking
you
for
might
my,
actually wind up using.
water. I'll find it. Okay, I'll
Okay.
find it. I
have-
understand. That's not the one I was using.
300 ohm resistor and a 19 picofarad capacitor at 21.2 megahertz. So we know that we go over 300 and we know it's negative, and we only seem to have one choice. So if that formula works out to 400, then we're good, right? I think they did these to force you to learn the reactance formula.
That one comes up to negative 395.
That's about what it is on the chart. I got 395 also. Of course, I rounded it. I think it's probably. You missed an easy one.
So easy. I'm just, I
Okay.
know everything now.
When we start trying to plot things that are frequency dependent, and we may plot frequency on the horizontal axis, we typically make that a logarithmic axis instead of linear. So you can represent a much larger spectrum of frequencies in the same amount of space. And you can do the same thing, a logarithmic y-axis for the same reasons. Where if we represent things in decibels, for instance, that's a logarithmic type of scale. So what type of y-axis scale is most often used for graphs of circuit frequency response?
Random graph.
Scatter. Logarithm.
Oh, very good. That was the last one. All right.